Okay, good morning. We're on page 362, and we're going to be talking about convergent boundaries today. You've seen them mentioned in the previous pages, but now we're going to talk about them in more detail and what sorts of features are associated with convergent boundaries. Remember that convergent boundaries are boundaries where two plates are pushing together. The type of stress that's involved with two plates pushing together is the stress known as compression. Okay, so the collision of tectonic plates at convergent boundaries causes rock to be compressed. This compression can cause rocks along boundaries to be pushed upward and folded, which form mountains. Most major mountain belts have formed near convergent boundaries. Subduction also occurs at convergent boundaries, and subduction is also associated with volcanic mountains, so you get volcanic mountain ranges along convergent boundaries, island arcs, and deep ocean trenches. So, features associated with convergent boundaries: folded mountains. I'm just going to put MT in folded mountains. Volcanic mountains. Trenches, deep ocean trenches, and island arcs. Okay, so we're going to talk about the features quickly. Feature number one that's associated with convergent boundaries: folded mountains. Okay, collision of two continental plates can result in the formation of high mountain ranges. Continental rocks are relatively light, meaning they're not as dense, okay, and resist downward motion. So the plates tend to be pushed upward by compression and folded and faulted, forming folded mountain belts. The Appalachian Mountains are folded mountains, and they occurred when the North American plate had collided with the Eurasian and African plates. So this happened a long time ago because we know that the Eurasian and African plates are now a fair distance from the Appalachian Mountains. Does anybody know where the Appalachian Mountains are? If you take your little map here, the Appalachian Mountains are these mountains right here. Okay. Okay, so, sorry, I paused. We had an interruption. So the Appalachian Mountains are here in the United States, okay, and they are a folded mountain range, okay. The Himalaya Mountains also began to form when the Indian plate collided with the Eurasian plate. The Himalaya Mountains here's the Eurasian plate up here. This right here is the Indian plate because it's got the country of India on it. And right along this line, remember that the lines indicate plate boundaries, right along this line is where the Himalaya Mountains are, okay? And it was caused by the Indian plate converging with the Eurasian plate. Okay, so two examples of folded mountains. The Appalachian Mountains here, Himalaya Mountains here. Okay. All right. Fault block mountains sometimes occur when two continental plates converge. Basically, you've got rock being thrust up and over another block of rock, and you kind of get breaks periodically. Okay, so those are fault block mountains. Okay, I'm not going to write it down, but you guys can. What's the process by which folded mountains form? Folded mountains form as a result of convergent plates, converging plates which cause rock to be compressed and pushed upward and folded. Okay, so features for convergent boundaries. We just talked about folded mountains. Okay, so we've talked about folded mountains. We're going to talk about volcanoes next. Okay. When oceanic and continental plates collide, the denser oceanic lithosphere subducts, meaning it's pushed beneath, the less dense continental lithosphere. As the oceanic lithosphere sinks, it encounters higher temperature and melts. Magma rises up through the lithosphere to the Earth's surface. Over time, a chain of volcanic mountains called a continental volcanic arc forms. An example of a continental volcanic arc is the Cascade Mountains in the Pacific Northwest. Okay. So really volcanic, over here, volcanic mountains and island arcs, they sort of go together. Okay. Volcanoes also form when two oceanic plates converge and one sinks beneath the other. In this case, the collision results in the formation of volcanic island arcs, and the Philippine Islands are a system of volcanic island arcs that have formed from oceanic plate convergence. Okay. There's another island arc that I want you to know about. I'm not going to have you worry about this photo too much. And instead of that question, I'm going to use this. The Aleutian Islands. Okay, so the Aleutian Islands are an island arc that was formed because the Pacific and the North American plates are converging. And I'll show you where that is in just a minute. Okay. All right, so we're going to go back to the map. This map is actually in Lesson 1. And I need to show you where the Cascade Mountains are, the Philippine Islands, and the Aleutian Islands. So here we go. All right. Your Cascade Mountains are in here, okay, in this area. You have the Pacific Plate and the North American Plate converging, pushing together. Okay, so along here, Washington State, Oregon, etc. That's where the Cascade Mountain Range is. Okay. The Aleutian Islands are the islands that kind of trail off of Alaska. Okay, so and the map kind of cuts off the Aleutian Islands, but the Aleutian Islands are out here, and what you have is you have the North American Plate up here, the Pacific Plate here, and again you've got a convergent zone. They're pushing together, and you get this arc of islands, and it literally is an arc. It looks kind of like a bent little rainbow. Okay, then the Philippine Islands. The map. Philippine Islands are over here. Let's see. I'm having a hard time spotting some things. Philippine Islands are in here. Okay. Again, you have convergent boundaries. You have those plates being pushed, and one is being subducted under another. Which one is subducted? It's always the denser plate. So if you're talking about two oceanic pieces of lithosphere, the older, denser piece of oceanic plate is going to be subducted or pushed under. Okay. So far, it says what features are associated with convergent boundaries. We talked about folded mountains. We've now talked about volcanoes. And I'm going to go ahead and add island arcs up here because those are all sort of together. Okay, volcanoes and island arcs. Okay, and instead of answering question 13, hopefully you pointed out that the Aleutian Islands are an island arc. Okay, and then feature number 3 that's associated with convergent boundaries are ocean trenches, deep ocean trenches. Ocean trenches are the deepest landforms found on the ocean floor. Some ocean trenches form where one oceanic plate collides with and slides beneath another oceanic plate. A lot of times you have volcanic island arcs forming parallel to that ocean trench. The Aleutian Islands, which they point out right here, the Aleutian Islands would be an example of that. Okay. Other ocean trenches form where an oceanic plate is subducted beneath a continental plate. Great example of that is over here. It's kind of hard to see on mine, but you can look at your own copy. There's a little red line along the west coast of South America. That's the Peru-Chile Trench, because this is the Pacific Ocean, and it is converging with both the South American and the North American plate, and the Pacific plate is being pushed underneath or subducted underneath the South American plate. So there is a trench that runs right along the coast, right off the coast of South America. The deepest known trench is actually the Mariana Trench, which is over here. Okay. There's actually a little island arc here called the Mariana Islands. Okay. But the Mariana Trench, is the deepest trench that we have discovered, and it's over 11 kilometers below the surface of the Pacific Ocean. It's really deep. Okay. This would be the Mariana Trench right here. Okay. This is the Filipino plate, and it is being converged, subducted under the Eurasian plate, and then also the Pacific and the Filipino plate are converging also and forming that ocean trench. Okay, so that's it for features associated with convergent boundaries. We have folded mountains, volcanic mountains and island arcs, and trenches.